This is a quadratic trinomial, x squared plus 2x plus 5. This quadratic trinomial can't have the same two numbers multiply to give me 5 and add to 2. So we have a problem. We can't use this method to factorize, and we need to use the method of completing the square. In this method, we have to take the first two terms and turn it into a perfect square. Now, a perfect square means I have the same two numbers that add to give the middle term and the same two numbers that multiply to give the last term. So the 2x tells us it has to be 1 plus 1. Therefore, our last term is going to be 1 times 1, which is 1. But by adding 1 times 1 to our trinomial, we've completely changed it. And changing it is no good. So now we have x squared plus 2x plus 1 plus 5. What can I do to make it the same but still have the perfect square? I can actually take 1 away. It's like the plus 1's not there at all. But this helps us to factorize. So the perfect square now becomes x plus 1 all squared, and plus 5 minus 1 is plus 4. And now we are factorized. Some trinomials, like x squared plus 4x minus 13, can be factorized even further. So by completing the square, we know that 2 plus 2 equals 4. So we're going to have x squared plus 4x plus 2 times 2 minus 13 minus 2 times 2. This is the new bit we've added in, and then we take away the new bit to make it look like it was never there in the first place, but we can now factorize. So we have x squared plus 4x plus 4, which is a perfect square, and we have minus 13 minus 4, which is minus 17. So this becomes x plus 2 all squared, because it's a perfect square, and we're taking away 17. Now I'm going to show you something else, and we can factorize this further, because I have the difference of two things. So I can turn 17 into a square number, and it becomes x plus 2 all squared, take away the square root of 17 all squared. Because if I square a square root, it's just 17. Now I have a difference of two squares. So I have x plus 2 take away root 17 multiplied by x plus 2 plus root 17. And my trinomial I started with at the top is now fully factorized.